Okay, guys, this is the final example from chapter 13b. Now, like I said, we've looked at this unit circle and we've looked at this idea before. If you didn't quite understand why this point could be written as cos theta, sine theta in the previous example, this also kind of re-explains that idea as well. If I have a unit circle, which means my radius here is going to be 1, because it's a unit circle, means my radius is 1 at all points. That's the premise behind this particular diagram. So if I have a radius of 1, that means that this point here is 1, this is -1, and 1 where it cuts my x and y axes. If this is 1 and I do a little broken line down to here and create a nice right angle triangle, I could say, well, the height here is going to be equal to my y coordinate at this point kind of along the top. So I can say this height here is going to be y and my length along the bottom here is going to be x. So before we get to the sine theta cos theta part, let's just rewrite this as being x comma y, just the x coordinate at that point, the y coordinate at that point. If I take this and I do my trig ratios from here, and I make this angle here theta, then I find that sine theta, which is equal to my opposite over my hypotenuse, is going to equal y over 1, cos theta equals x over 1, and tan theta equals y over x. Again, just using our trig ratios. If you want to explain this in more depth, like I said, feel free to ask me in class. We have looked at this a few times, so I think it's okay to go a little bit quicker with this explanation. Once I'm here, anything divided by 1 is just itself. So I could say, well, that means sine theta equals y, cos theta equals x. Now, this idea where sine theta is equal to y and cos theta is equal to x is how we can substitute into my coordinate points all the way up here, which is where I get the idea that x is equal to cos theta and y is equal to sine theta. And again, that's just to kind of help highlight the example before, in case you're a little unsure where those particular values came from. So once I've established this, there's two cool ideas. It's kind of like a bit of an extension on what we've already discovered. Idea 1 is if sine is equal to y and cos is equal to x, tan theta equals y over x, I can also say that tan theta equals sine theta over cos theta. This is sort of the proof for where this idea here comes from. The second idea that's really neat is if I do Pythagoras' theorem, a squared plus b squared equals c squared, in this case, my lengths are x and y, so I get x squared plus y squared equals 1 squared, which in this case, 1 squared is just going to be 1. If I substitute in cos theta for x and sine theta for y, which I've kind of established is true based on these two ratios, then I wind up with cos squared theta plus sine squared theta equals 1. This identity here is what we are going to look at, and we're also going to look at this identity here in our next example. Two really, really important ideas that help us answer a range of different questions. If I come across to these two questions here, and here's my Pythagorean identity. This is on your formula sheet as well. So this is on the formula sheet. If I look at my Pythagorean identity and how this impacts my questions, if I'm asked, like I am in part A, to find cos of x, and I'm told that sine of x is equal to 0.3, and I know my angle is between 0 and 90 degrees, or 0 and pi on 2, then using my Pythagorean identity, I know that cos squared x plus sine squared x equals 1. I don't know what cos is, so it's just going to stay as cos squared x. However, I know sine is equal to 0.3. So it's going to be plus 0.3 squared, which is going to give 0.09. That's all going to equal 1. So you can see now I can do some rearranging of my equations and I can wind up with some kind of neat results. So I can now subtract 0.09 off each side, and that's going to give me cos squared x equals 0.91. Square rooting both sides gives cos x equals the square root of 0.91. If it's tech-free, we can rewrite 0.91 as being the square root of 91 over 100. Square the top, square the bottom. That gives root 91 over 10. If it's tech active, you can just put this in a calculator, and this is how we can solve for cos x. I know tan x is equal to sine x over cos x, which in this case is going to equal 0.3 over the square root of 0.91. And at this point, just pop that in the calculator. That's going to give 3 root 91 over 91. So like I said, 2 rules or 2 identities. I've got this identity here. I've got this identity here. I can use that to solve for different values based on just one piece of information, which is kind of neat.